Hi, this is a video for COM 345. This is about the notion of compilation units and the separation of code between header files and CPP files, and the association notion of that includes across files, as well as forward references that you may sometime have to do, as well as the include guards that come with the inclusion of the header files. Now, we've already covered that in class, but I felt I had some indications showing me that some students did not very well understand how to do that. And this is a fundamental thing to do. So I figured that we needed more practice on this aspect. So here I'm giving you an example. So here I'm going to show the example, or briefly show the example I've designed. It's actually one of the questions that I had in the midterm exam that I have now made public on the Moodle. So essentially was providing you with an initial program that was only in one file. And then I wanted you to separate this code into 3 different compilation units. The risk driver file, that is this file here that contains mainly the main function, as well as the player.cpp, as well as country.cpp compilation units, both of which coming with their own header files. Now, as we saw when I discussed in class about this question, there was a lot of things involved that many students did not apparently understand very well. So this code is there along with this video and the slides that come with this video. So please, as you listen to the video, maybe you can look at the code. So that actually is resources that come together with this lecture. Now let's go to the slides. So these slides are really organized around the example that I gave. So if you want to follow what's happening, maybe it's better for you to have the example actually open in your favorite IDE. So here we're going to talk about notion of compilation unit. Again, these are things that we already covered. There's some of the things I'm going to repeat inevitably, but I'm going to try to give more explanations. These are things we already covered, but I'm going to try to show it from a different perspective, and then unify all of these things together in a way that it somehow provides you with some kind of method somehow to apply on how to do these things, how to organize your code when there's header files, CPP files, how to do the includes, what's the best practice, why is it that the best practice is actually the best practice, so on and so forth. What's the reasons why certain practices are found to be better. First, let's go and describe what is first the compilation process, which includes the notion of compilation unit. So, when you compile your application is composed of different compilation units. Compilation unit in C++ is a CPP file. Like when you compile your Java program, you have a bunch of Java files, which you compile into .class files, which are then somehow loaded by your Java virtual machine. Now, in Java, your compilation units are your individual Java files. They are each compiled separately by the compiler, and then they are somehow loaded by the JVM. In C++, it's a little bit different. Your compilation units are your CPP files. The fact of the matter is that there's also your header files. So that's why some people are often confused. Why is there CPP files, header files? What's the goal of each of these files? What should I put or not in these files? That's a bit what I'm going to explain in more details here. but let be known that your compilation unit is a CPP file. Okay, that's what you should understand. Your header file are there only as some kind of accessory for the compilation of and better organization of the compilation of your compilation units, which are your CPP files. Okay. So, and one of the things that is different is also about how it's being compiled. Of course, C++ is a compiled language. So what that means is that it will compile your code. In the case of C++, it's going to generate your object files, one for each of the source files that you provided to it. So each CPP file is individually eventually compiled in a .o file, which is the object code, which is the executable code, but only for this compilation unit. Then the linker will actually take each of these .o files and will somehow link them together, because most often it would actually, each of your compilation units would actually be using one another. So for example, a certain compilation unit may provide the implementation of a certain function, and this other compilation unit here is using this function, but is not defining this function. So then the linker is going to have to figure out that this function that is being used by this compilation unit is actually provided by this other compilation unit, making the link to get between these two compilation units, hence the name, right, of linker. So roughly the same thing is happening in Java, but it's much more behind the scene, I might say. So happening as you load and execute your code and the generated code in the Java virtual machine. So this is the three compilation units that there is in the example that that is associated with this lecture. So there's the risk driver.cpp, player.cpp, and the country.cpp. These are your three compilation units. So when you call the compiler to compile this application, it will compile player.cpp, riskdriver.cpp, and country.cpp separately. So these are three separate compilation exercises. Okay, it's not the same compilation. These are three separate compilation exercises or run of the compiler. And each of them will compile this and then generate the corresponding .o file or object file. Then it will compile this, generate the .o file, then compile this, generate the .o file. Then once they've all been compiled, then the linker will actually read each of these files, figure out, as I said before, which of these files are using some things which they don't define, and then we'll try to find these things that are used by some of those files, hopefully finding them provided by other .o files. Hopefully we'll resolve all the linkage problems. And if so, then we'll generate a unified application that you can execute as one unit, executable unit. Okay, so this is how our example is organized. Now, of course, here you see that there's country.h, player.h, and so on and so forth. So I'm going to explain gradually how this is organized. But the baseline here is that you have player.cpp, riskdriver.cpp, and country.cpp. These are your three compilation units. So, and you have your CPP files and your header files. So what's the difference between these two? What should they contain? What should they not contain? What's their purpose? So as I just said, a CPP file is the compilation unit. So when you call the compiler, you tell it to compile a CPP file. Okay, for the compiler, this is the essence of what is being translated. Now, what is being translated? Of course, this is a program, so there are some instructions to be followed. Okay, There are statements, there are functions, and so on and so forth. So yeah, you have a main function, starts executing the main function, then executes each of the statements. In some of these statements, there are going to be function calls. And when there's a function call, you need to branch to another function, execute this function, and so on. This other function might execute other functions, and so on. So essentially, what is the translated code is the translation of the code that you have in your functions. So the code is essentially a set of functions. So you see that this brings back to you brings you back to the essence of what C was. So it's easy when you have classes to forget that the essence is still that you're executing functions. Classes is just an artifice that was created, or an abstraction that makes you able to actually put functions inside some containers, some abstract containers named classes. But as far as the program is concerned, what it does is it executes code which is embedded in some functions that you call. Okay, that's why you might say your CPP files, what they are, it's a set of functions that it defines. Okay, so that's why you should think your CPP files contains a set of functions. The CPP file, you should not think of it as it contains a class. It contains a set of functions. Some of these functions, yes, are member functions, but then as we will see, if they are member functions of a class, then you somehow have to define or declare what this class is to specify in what class that these member functions belong. Okay, but it's very important that you understand your CPP file is just a set of functions that is going to be translated by the compiler. That's what's going to be executed at runtime. So CPP file contains the implementation code of a component. Implementation code is what are the instructions inside of each of the functions. Like a class declaration, it's not something you can execute. It's just a declaration. What you can execute is a function that is a series of statements that actually change values in your program and are passing values to each other and are processing things and so on. So what is really the essence of the execution is the code that is inside of your functions. And that's what is in your CPP file. Then, okay, so what is in the CPP file? The member functions implementation code or the member operator implementation code. So we saw this lately. Either functions or operators, if they are members, they will be their code will be provided in the CPP file of that component of that compilation unit. So you essentially you're creating essentially a compilation unit is a group of functions that you somehow are grouping together and that you say that are belonging to the same group of functions. Now, if you think in terms of Java, this is very natural to think that what is this group of functions? This is the group of functions that are the members of a single class. As we saw in C++, you can have in the same compilation unit more than one class. You can also have free functions or free operators. And then that makes it more complicated as to what is a group of functions, because you have free functions and potentially multiple classes in the same file. It gives you much more freedom as to what is a group of functions. It's not the group of functions of one class anymore. It's much more complex than that, potentially complex than that. Okay, so yes, you can have a free functions implementation code or the free operators implementation code. There is also, as we saw in the example, if you look at the code as explained in class, there's also sometimes some classes will have static members. If a class has static members, then there has to be somewhere to initialize the value of this static member. Generally speaking, you would initialize the value of a static member in the CPP file. Why? Because a variable initialization is somehow a statement. It's a statement that you put in the global scope. It's a statement that, given a certain member of your class, which is static, will assign a value to this member. And this must be done in the global scope in the CPP file. You may also have some global variables declared in your program that may be associated with a specific compilation unit. In this case, well, it's less clear whether the variable should be declared in a header file or in a CPP file. But if they are to be local variables and you diminish the possibility that you would have redeclaration of these variables, most often it's better to actually put your global variable declarations that are somehow linked, that are related to a compilation unit in particular, that you would put these global variables definition inside declaration inside of the CPP file. So in conclusion, CPP files are the source files. So this is essentially the main source file. This is the compilation unit. So these are the files that you will instruct the compiler to compile. Now, if you use a command line compiler, it's very clear. When you compile your application, you have to tell the compiler to compile every CPP file. You call, for example, you use G++, you pass to it the list of all the CPP files in your directory or your application or your code. However, if for people that use an IDE, it's not that clear, because in your IDE, you sometimes have like a folder where you have your source files, which are the CPP files, another folder for the .h files, and then you just click compile and you don't know what's happening, but it basically executes it compiles the code. What it's actually doing is exactly what JCC would be doing. It actually goes and it finds all the CPP files in your folders and will compile these files. It does not call the compiler on the .h files. It calls the compiler on the CPP files. If it happens that these CPP files are having a hash include of the header files, then they will be included in the compilation. But the compiler is not told to compile a .h file. It's told to compile a .cpp file. So then what are your header files? Why do you have header files? That's what I'm going to try to make it more clear here. So the header files contain declarations that are used by their associated CPP file or other files. So the idea is, as I will say later, explain more in more details later, is that when you compile the code in your CPP files, they, for example, contain the list of functions that belong to a certain class without including the class declaration. As we will see later, when you compile your CPP file, there is inevitably a lot of entities that are referred to in the CPP file that are not declared in the CPP file. For example, the class itself is not declared inside of the CPP file. The reason being that if the class would be defined in the CPP file, and you want this class to be usable by another compilation unit, then you would need to hash include this CPP file. If you hash include a CPP file from another CPP file, what you're doing is that you're merging these two compilation units into one compilation unit. Okay, so the biggest no-no here is to think that you can hash include a .cpp file. Okay, so never should this happen. You can do it, but you should never do that. So that's why you should not have a class declaration in a .cpp file if you want this class potentially to be used by other compilation units. That's why you would put your class declaration in a .h file, which would then, and this .h file does not contain code, it just contains declarations. Right, that does not contain the implementation of the functions that are listed as the members of the class, just contains declaration of these functions. What's the name of these functions? What are their parameters? But does not contain the code. That's why when you include this code into another compilation unit, it does not compile the executable code. Thus, it does not include the compilation unit into the other compilation unit. So why you have header files is to be able to group together your declarations of, for example, of a class the declaration, so that you can actually use this class declaration or this class inside of another compilation unit. So that's what is the use of header files. That's why you have header files. That's why you have CPP and header files. So the header files contain declarations that are used by the associated CPP file. So for every CPP file, generally speaking, you have a corresponding H file. So a header file is very often hash included by its own CPP file, but can also be hash included by other files, either other CPP files or even other H files. Okay, we'll come back to that later. Then the things that are included in the header files is the class declarations that declare all the members of a class. That is a class that is declared or defined or used inside of this compilation unit. Then the free function declarations related to this class, or the free operator declarations related to this class. When you declare a free function or operator, very often it's actually related to a certain class. For example, it might be a free function that receives as a parameter an object of the type that this component or this compilation unit is defining. For example, here we have the type player that we're defining in this example. So it's possible you would define a free function that receives a player or that returns a player, or both. And clearly this free function, even though it's a free function, does not belong to the class. Clearly it's somehow related to this class. And it's possible that when you use objects of type player, you want to be able to use this function. So of course, then it's grouped together with the class declaration. And it's part of the .h file. So that if other compilation units want to use this class and these free functions, then they just hash include this header file. So conclusion, header files are not source files. When you, for example, you would use a GCC to compile your code, you don't go GCC file name .h. You could, but that's not how it should be done. Okay, .h files, they are not compilation unit. They are there because they are used, they are included by a compilation unit. So header files are not source files, they are accessory files that are can sometimes be included in the compilation process of a source file. So you should really understand your header files as being, it's an accessory file that enables you to share declarations across different compilation units. And the real code of this compilation unit is what is in the CPP file, which itself is using the code that is inside of the .h file. So this is a screenshot of what the example. So you see here, I put the things here in pale gray so as to not attract attention for this moment. So what I want to draw attention to here is that, well, for example, this is my player.cpp compilation unit. So as I said earlier, it's a list of function or member definitions. Like this is the definition of a constructor of the class player, which is a function. This is a definition of a member function of the class player. This is a definition of this static member of the class player. So you see that it's somehow a statement. So it's something that you execute. It's executable code. It's a statement, just like the statements that you have here. It just happens to be a statement that is in the global scope. So it's a statement, so somehow it belongs to a CPP file. It could be in the .h file, but normally you don't do that. You put it in the CPP file. And it's a statement that actually resides in the global scope. So as we saw in the exam, some people actually put this here in the driver file. Well, the thing is that this is a definition that belongs to the player class. So it should be, logically, be part of the player.cpp file and not another compilation unit. Even though it would work, that would make it so that if you're trying to use the player class from another compilation unit, if you put this in a specific compilation unit outside of this one here, then it's going to be missing when you're trying to use it in another context. That's why it should be here. Then here I have my stream insertion operator for a player. So it belongs with the player.cpp compilation unit. Here I have a global variable that is declared that is somehow about player. So I decided to put it here. We'll see later that if you want to use this global variable from another compilation unit, you would have to refer to it as extern. Okay. See that later. Now this is my player.cpp. You see this is a list essentially of definitions, right? All definitions for functions or some statements that are defining some values that are used by assigning a value to variables that are used by the player. Then, of course, what's happening is that there's an associated player.h file. This player.h file, what it does is actually provides the class declaration. Here you have the class declaration for the player, which of course is stating all the members, including the members that are implemented here. Okay. Could have the code here, but then that would have a special meaning in C++. That would mean that these functions would be inline. Generally speaking, you don't do that. The reason why I'm very often asking in an exam question to have the members as non-inline, because I know people are Java people in my course. They've learned to use Java, so they might think that the function definitions go in the class declaration as in Java. No, it does not have the same meaning as in Java. Generally speaking, you have your class declaration in the .h file. You don't have the bodies defining them here, and then the bodies are to be found in the player.cpp file. Because people are coming from Java, some people think that somehow the main file is the .h file because it contains the class. And then may think that this is the accessory file that contains the definitions of the functions. This is actually exactly the inverse that you should think. You should think that the player.cpp file defines the code that you're going to execute. Some of these things, for example, belong to a class. This class has to be declared somewhere. Where is it in the .h file? That's how you should think about it. So you see that if you learn Java and then you go to C++, there's a lot of things that you may have misconceptions from how you think in Java. You have to somehow erase some of these conceptions and now think about in terms of C++ and not Java. If you try to mix the two, it's going to be leading to confusion. Another example here, this is my country.cpp, the list of all the member functions, the free operator here, the definition of my static member here, and the definition of this global variable here that relates to country, which I bundled inside country.cpp compilation unit. And then in my corresponding .h file, country.h, I have my class declaration, and then the declaration of my free insertion operator here. So if, for example, I have another compilation unit, as we will see later, that wants to use the country class and the stream insertion operator, all they have to do is go #include the name of this file. Okay. We'll see that there are some variations of this, but generally that's the idea. Then there was the, I would say, the driver compilation unit. This one is essentially containing only one function, the main function, which is a free function. So it doesn't have a class. It doesn't declare, it doesn't use a class on its own, and it uses only the main function. So that's why it doesn't have its own header file. So you see, you can have a CPP file that does not have a header file. Here you see that I have this extern declarations here. Here you have to understand that this risk driver.cpp is separate. When I compile this here, the compiler, I tell the compiler to compile this, it compiles only this here. So this here is using num players. Well, you might say, well, I have declared it in this here, num players. So you might say, well, it's going to find it here. No, because this is another compilation unit. Okay? The compiler is not aware of what it did when it compiled something else. These are two separate compilation exercises. So when the compiler compiles this here, if you would not have this here, then you would say num countries is undefined. So the fact of the matter is that they have been defined, but they have been defined inside of the CPP file of the other compilation units. Now, if I go back to the this here, so you would see that for example, my global variable about players would actually be here in this object file, whereas my risk driver here is using them from here. So the linker would need to be able to link the use of these variables, these global variables here and here, and be able to use them here. So yes, the linker will do that, but however, the compiler, when it compiles this here, if you don't put a declaration declaring what is num players, the compiler will come here and say, well, num players and num countries, these things don't exist. So you need to have somehow a declaration of these variables, but here you declare them as extern, essentially telling the compiler that, yes, these variables exist, but the linker is going to find them somewhere else when the compilation is finished at the linkage time. That's what's meaning of extern here. Okay, let's move forward. So then there's an issue about includes. Okay. So seems to be, at least to me, seems to be a simple problem. But then when you start thinking about it, there's so many different ways of doing it. You talk to people, you have experienced people, they sometimes argue as to what's the good way of doing it. So basically here I'm going to present one way, which is I'm hopefully presenting it in a systematic way and explaining why I'm doing what I'm proposing to do. And then I'm going to expect that you're going to use this in the subsequent questions that I will give you in the exams. Okay. It's not that I want to force you to into my way. Is this that, you know, for the students that are lost and don't know exactly what to do, at least they will have some kind of systematic way to apply if they don't have their own way. Of course, if you have your own way, then I'm probably going to ask you to do things that you're not used to. You're going to be annoyed, but you know, that's what it is. This is a course. We have to tell people to all work in the same way so that we can grade in a uniform manner. Okay, so what's happening here? First of all, why do we need includes? Okay. So let's say you have the country.cpp file here, which we saw before. So you have this here. This is here my function named country that belongs to something named country. Now, country is not something that is defined yet. So if you don't include anything, let's assume we don't include anything yet. Okay. And then you compile this, the compiler will say, what is country? What is country? What is string? What is country again? Country again. What is this country? O stream. What is this? I don't know that. Get name. I don't know that. So if you just compile this code here and you don't tell the compiler where to look for to find some other definitions that will provide, for example, a definition or declaration for country, the compiler is just going to say repeatedly, well, all of these things that you're naming here, that you're trying to compile, they don't make sense to me. They've not been defined or declared. Okay. So that's what is the hash includes for, is to include other files that would provide the declarations of these things that you want to use. Okay. So you're essentially telling the compiler, you know, when you compile this file here, just go to all these other files here, read these files. It's going to tell you a bunch of definitions so that when you're going to come here, you're going to know all of these things. And then suddenly country and owner and name and toString and string and so on, it's all going to make sense to you. Okay, that's basically what's happening. You're telling the compiler where to go to find the right definition so that it can make sense of what you wrote here. That's why you need to have some includes. Same thing happens in Java, but somehow in Java, it's kind of more streamlined. Here, it seems you have to do everything by hand, and it's not, there's different ways of doing it, so it's not clear how to do it exactly. So, okay, so yes, so you have code, you use things that are defined or declared somewhere, but not inside of this code here. Country in this piece of code here, country is not defined. Owner is not defined. Name is not defined. All of these things here, they're not defined. So you have to tell the compiler to read other files that will provide with these definitions or the declarations, so that when it reads that here, it will be able to figure out, for example, when it will go hash include country.h, it will find the declaration of the country class that includes all the members of the country class. So when it comes here, country : country, then it will look literally in its table, symbol table that it compiled. It will know that or not whether this default constructor for the class country was declared in the class declaration. If it is, then it will here compile this and so on. And if it's not, it will report that this member function was not declared in the class, right? So that's why we need includes. And the way to tell the compiler is to go hash include the name of a file, which literally redirects the compiler to go read this file. And once the file is read, then come back here and then execute the next thing, which is read another file and so on and so forth. So eventually when it comes here, it knows everything about that here. So you see that your job when you want to determine what is it that I need to include is to figure out what are all the things in this file that the compiler would not know if you would not have any include. So you have to somehow scan over the code that you have, and for every of the things, you actually provide a hash include. So that applies, of course, to your CPP files. However, it also applies to .h files, because, for example, let's say you tell the compiler, compile my compilation unit country.cpp. Compiler says yes, comes here. The first thing you tell it is go read country.h. Then it goes to country.h, and then suddenly start seeing player and string and so on. So if you did not have included, put some includes here for this file, then the compiler would come here, player. Well, I don't know what's player. I don't know what's string. I don't know what's ostream. So even the .h files need to have their own includes also. Every file need to have their own includes if they are using something that is declared somewhere. Okay. What I'm proposing here is that the list of things that you include includes the list of all the things that is used inside of this file. Okay. I'll come back to that later. So what is it that we should include, and how should we include it? That's the next question. There's different ways to do it. Okay, so as I mentioned before, prior to encountering some identifiers, because, for example, player, like this here, player here is an identifier, string is an identifier, ostream is an identifier. From the perspective of the compiler, these are identifiers. They are like a stream of characters that is not a keyword, hence it is an identifier. So then it starts to look up in their symbol table of things that have been defined or declared. And then if it does not see some of these identifiers, then reports undeclared identifier. That's how the compiler does it. So from the compiler's perspective, when it sees an identifier, it's expecting to see it in the dictionary of things that have been declared before. So if it sees an identifier, looks in the dictionary, it's not there, and it's going to report undeclared. So there are actually two ways for the compiler to actually put an entry in their symbol table. First, you could have things like, there's other things, but things like a forward class declaration. Let's say, for example, the compiler, let's be more specific here. Let's say you would not have any includes here. Compiler comes here and says, oh, player. What is player? Well, player is not been compiled yet. I don't know what is player. So what is it that you could have had before that would have informed the compiler about what is player? Of course, in our case, player is a class. So yeah, there are two things you could have put before this code here. Two things you could have put here to inform the compiler about the fact that for you, player is a class. So that the compiler from now on would know that player is a class. One of those things is a forward class declaration, where you just basically say class player semicolon. This right away, when the compiler reads this, it's become informed that there is such a thing as an ID player, and it is a class. Okay. So right away, this allows you to use player as a class, as a type. Okay. So that's one of these things that you could do to inform the compiler that player is a class. Next thing you could do is being much more informative and then provide the class full declaration, for the full class declaration of the class player. Basically, you go again, class player, instead of go semicolon, you have this specification here about what are all the members of the class. So yes, this is somehow the same, except that this is providing more information. Okay. So what you could have before this here is other class player semicolon or the full declaration of the class. Now it happens that here what I'm asking you to do, here you see that I'm asking you to have class player. So then somebody might say, well, why didn't you just hash include the whole thing? Sorry, the country dot the player dot h. You could do that, but I will explain later why this is a better idea or a more systematic way that is going to avoid some problems. The idea is that if it's sufficient for the compiler to be reading class player semicolon, then that's what you do. But if the compiler needs more than that, then you would go hash include player.h. In this case, as I will explain shortly, the compiler would be able to compile this by only having seen class player semicolon or a forward declaration of the class player without providing the body of the class declaration. Okay. So here's the explanation as to when is it that you actually need to have the full class declaration. Full class declaration is really, really needed only when these two conditions are true. Either of these two conditions are true. First, either the members of the class are referred to in the code. So, example, if in the code here, okay, so here you have co.getName. What is co? Co is this variable here, which is of type country. So here you're essentially referring to the member getName of the country class. Now, if at the top here, you would be saying, you would be providing a forward class declaration saying class country semicolon, then that might work for this here, but that would not work for this here. This here only needs to know that country is a class. So a forward declaration would work for this here, but would not work for this here, because here the compiler needs to know what are the members of the country class. So in order to process this, the compiler needs to have the full class declaration. That's why here you need to have absolutely hash include country.h and not a forward declaration, because it's not sufficient to compile actually this here that refers to the members of the class or one of the member of the class. Okay, so it's really needed either when you refer to the members of the class, which are provided in the full class declaration, or when the size of an object of that type is required. So, well, what does the size have to do? Okay, and what does the class declaration have to do with size? Okay, so if you remember when I explained how things are stored in memory, when you store an object in memory, you have to reserve enough memory, a block of memory that can store all the data members that are declared in the class. In this case, for the player class, there is the vector here, and then there's a string here. So whatever it is, when you create an object of type player, it needs to be of size of a memory block, reserve a memory block that can actually contain something of type vector and something of type string. Okay, so that means if you're declaring a variable of type player somewhere, then the compiler needs to know what is the size of memory block to reserve for this variable. Hence, it needs to know what is the list of members of this class, including the data members, which the compiler will compute by doing a running sum of the size of each of the data members. Okay, so if you declare a variable in your code if you declare a variable of a certain type inside of your code, which is not happening here, but if you would, in this code here, declare a variable, for example, of type country, then you would need to actually have hash include country.h. Because that implies that the compiler needs to know what is the list of all the data members of this class to compute what is the size of memory block assigned to this variable. Okay, so and that applies only to non-pointers, because if I would declare somewhere, I don't have this here, but let's say I would declare a variable inside of this code block here. So if it's of type country, then I need to store a country object on the stack frame of this function. However, if it's a pointer to a country, then the only thing I need to store on the stack frame is a pointer to this object. The object itself resides outside, potentially on the heap. So the object does not reside itself on the stack frame, only a pointer. So the compiler only the thing that he needs to know is what's the size of a pointer, which is independent of the size of the class. That's why if you have only pointer declarations, you don't need to hash include the country.h file. You only need to have a forward class declaration in order to process declarations of a pointer. Okay. Another reason why the full class declaration might be needed is when you have a class declaration in your file. Let's say I would be compiling this one here. So I would be compiling this file here, the .h file here, compiling this file. Let's say, it's not the case, but let's say the class country would inherit from another class. Then what's happening here is, if you remember, when you store an object, the way that you determine what is the size of an object is the size, yes, of all the members inside of this object. But this object, if it inherits from another class, then it also contains them a part of this subclass here. The object of the subclass contains another part, which is the part that belongs, that is the members of the inherited class. Okay. So that's why if you have inheritance declared here, then that would force you to have the full class declaration before here, so that the compiler has access to the data members to compute the size of an object of this kind also. Okay. So if you have inheritance, that somehow forces you to hash include the file that contains this class declaration, this other class declaration. So you see that it always have to do with size, the size of a variable or the size of a part of something that you inherit. So then full class declarations are generally provided in header files, as I explained before. Cpp file provides the members of a class. The class declaration is in the header file. So your full class declarations are generally in the header file. So that's why very often at the top of a file, you would see hash include blah, 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 .h, blah, 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 .h, and so on. So what you include is header files because they contain, mostly because they contain class declarations. But they also contain the declarations of some of the free functions or free operators that will be associated with this class that you may want to use somewhere else also. That's another reason why you might hash include your H files. So then if a class is declared in your .h file, then what you need to do is to hash include this file. So for example, here, I was referring to get name of country. So I need to have hash include country.h. Here, I'm referring to get name of owner, where owner is the owner member of the country, and owner, if we look in this file, it's actually a player. It's a player member of the country class. So this is essentially referring to the get name member of the player class. That actually forces me to have hash include player.h because I'm referring to a member of owner, which is of type player. Okay. So you see that what you need to do really is to be fully aware of what exactly your code is actually using to figure out whether you're going to use a hash include .h file or hash include not hash include, but a forward declaration. Here I was using forward declaration because here I have only player pointer. So I need only to have a forward declaration. Okay, I'll come back to because some people might still be, well, why don't you always do a hash include the .h file? If you remember, and that's what is part of what is answered here. So here in this example, which was purposefully chosen as an example that has a circular dependency. Here I have a country contains a player, and then the player contains a vector of country. So player uses country, country uses player. So if you compile this, you put this in player.h and you put this in player.country.h, and here you hash include country.h, and here you hash include player.h, and you try to run this to compile this. Then the compiler is going to try, for example, to compile this one, and it's going to say, oh, let me read this here, and then this will say, oh, go read this here. But then it's going to go in a circle, and then it's not going to work. Well, you might say, well, if you have include guards like your pragma wants here, it's going to prevent that it goes in circle. Yes, but it's going to prevent it to actually. So what's going to happen is that, so you start here, and it's going to say, read this here. You're going to come here, and then first thing it's going to do is go back here, and the pragma once is going to prevent you from reading this. Thus, you're not going to be able to compile this because it uses player. Okay. So if there is a circular dependency here between your classes, such as in this case, you need to avoid to have hash include the other file in each of the files. How do you avoid it? By using forward references, forward class declaration. Okay, and then if you look carefully inside of the player, here this is using a country pointer, and here in the country it's using player pointer. So in fact, neither of these classes, neither of these files actually need to have hash include of the other file, because they're only referring to the type itself, which this will make it, having a forward declaration will totally make the compiler be able to compile this. And then you have a forward declaration for country here, and then the compiler is going to be able to compile this here. So here, by having forward declarations, you're avoiding the problem of the circular class dependencies. And that's why I'm proposing that if you don't have, you don't need to have, or if you don't need to have the full class declaration, you should use a forward declaration. So if you do this systematically, then this will avoid the circular class dependencies automatically. Okay. So that's here what you see here, I'm proposing some kind of method, you know, so you might say, oh, I'm going to look for a circular class dependencies, and then I'm going to insert a forward declaration in case I have a I have a circular dependency. Well, if you just do it systematically, as I say, you will not even have to be aware that there is a circular class dependency. If you proceed, as I said, when you have pointers, then you use a forward declaration. you're going to automatically avoid the problem of the circular class dependency. So the point is, if you don't have to read the whole class declaration, you should only use a forward declaration. Okay. Of course, if you have both cases in the same file, which is happening in this file here, the risk driver.cpp, here you might say, oh, player star, country star, oh, easy, I'm just going to make my forward declarations. However, you look here and you see that it's calling the player constructor, the default constructor of the player class. Here it's calling another constructor of the country class, the non-default constructor of the country class. Now, if the player wants, the compiler wants to be able to compile this and this, for this, it needs to know if the default constructor for the player class has been defined or declared. In order to do that, it needs to actually have access to the full class declaration. Same thing here. You're trying to use a specific constructor. So the compiler, if the compiler wants to process this, needs to know if it's available. The only way to assess that is to have the full class declaration of country, which is available in country.h. So that's why you need to hash include player.h and country.h. Even though here you're using only pointers, here you're actually referring to members of the class. Now, okay, so that's for the hash includes of your own files. Okay. Now, what if you want to hash include libraries? It's very common that people will systematically, I see that very frequently when I give exam questions, write some code that does this and that. And then some students will systematically, on top of all their files, they will have hash include IO stream using namespace standard. Even though the file does not use it, they just basically somehow an automatism in their mind that this is what all files should do. That's false, okay? And that's indicative that you don't know what you're doing, if that's what you're doing. You should have a hash include for something only if it's used in the file. There's no reason for you to have a hash include of something if it's not used in the file, if this library is not used in the file. So here I'm going to propose that you use something specific that somehow forces you to be specific as to what you are including. Okay. Now, first of all, when you to determine what libraries you need to include, of course, you need to look at your code. Okay? Well, somebody might say, oh, I'm just going to not include anything. I'm going to compile my code, and then the compiler is going to complain, and then it's going to tell me what I should include. Well, that's not how things should be done properly. You as a programmer should be aware of what you're using, and before you compile, you should put your own includes so that when you compile, it doesn't fail, that hopefully it goes well. A lot of people have this very bad habit when they're programming to just try something, compile, and then the compiler tells me something, gives me a hint about what to fix. Basically, they fix, compile, fix, compile, and so on until it works. And they're like, yay, it works, and everything is fine. Well, first of all, not necessarily everything is fine because it compiles. And then things like, for example, if you have hash include IO stream using namespace standard in all your files, looks like it's fine. But if you give this code to a senior programmer, they'll start pulling their hair off, right? Because evidently that shows that you don't know what you're doing. So it's not because your code compiles that it's correct code and that it's not indicative of misunderstanding on your part as a programmer. Okay, so how do you do it? So essentially you have to look in your code. For example, like here, I go all players. What is all players? All players is a vector of players. So here I'm going all players push back. So this is all players is a vector, and I'm trying to use pushback of the vector. Okay. Well, first of all, I didn't notice that. I should add this, but vector here, the declaration for vector tells me that I use a vector. But here, more, if I go push back here, I'm using pushback of a vector. Here I have all players dot at. All players is a vector of players. So I'm using the dot at member function of the vector class. These are all things about vector that I'm using. I'm using own countries dot pushback. Own countries is a member of the player class, which is a vector of countries. Then I'm basically calling pushback on vector again. Here, all players dot at, all players is a vector of players. I'm calling the dot at of a vector. Here I'm going all players dot at again. So that's dot at member function of the vector class. So this basically is all telling me that I'm using the class vector, which I will find, of course, into the vector library. So I'm going hash include vector. Then what I'm proposing, because some people might be like, you go hash include vector using namespace standard. Okay. Using namespace standard, what it does is that it opens the whole namespace. Okay. So somehow that will force the compiler to become aware of everything that is in this namespace. Plus, using namespace standard, if you did not have another using namespace before, let's say you have hash include vector, hash include IO stream using namespace standard, and it will force the compiler to become aware of everything that is in namespace standard of both of these libraries. So you see that it potentially is wasteful of resources because the compiler must then know everything that is in this whole namespace for both of these libraries. If you're using std cout, for example, so hash include IO stream using std cout, and the compiler needs only to be aware about cout inside of IO stream, much less wasteful. Plus, very interestingly, for your fellow programmer or teammate, is that here, right on top here, you're telling the programmer, I'm using cout. If you would have hash include IO stream using namespace standard, that doesn't tell you much to your fellow programmer as to what is it that you're using here. Here you're being extremely specific. Okay. Now you could be going hash include IO stream, and then you'd be going here std : cout. That would still work and would be doing the same. What I'm proposing here is that you put it on top of the file. Of course, here, one of the reasons that when I'm grading your answers, that I will see that you are including the right things and not things that should not be included, that I have a list of things that you have established that are to be included to compile this code here. Okay. So that's what I'm proposing that you do for the answers that I'm going to ask in the exams. And it's going to be stated in the questions. You have to use this way that was explained in this video. Okay. I know some of you probably have different habits. I know it's not fun to be thrown out of our habits, but that's what I'm going to be expecting, and I hope that you see some value of what I'm proposing. Now, this last thing, which I already explained, but I also saw that many people are seemingly not aware of, is include guards. The idea of include guards is that, as we see here, so here you have your a.cpp compilation unit. So maybe it uses a.h by using hash include a.h, hash include b.h. Fine up to now. But then what if a and b.h both hash include c.h? So that would mean when you compile a.cpp, you read this, then you go read this, then you become aware of this class C here. So then you finish reading this here, go here, and then hash include b.h, come here, hash include c.h, come here, read class C again. If you read, and the compiler does not know that this is the same class C. All it's reading now is that, oh, class C, and then look in their dictionary and sees class C is already there and goes, class C is already defined. It's a redefinition or redeclaration of class C. Okay. Compiler is not intelligent. All it knows is as it creates a dictionary of things that they know, and then somehow they come back to the same thing, but they don't know it's the same thing. All they know is that they're reading another class C. Class C is already defined. Redefine class C. Compilation fails. So that's why what you need to have is what is called an include guard to prevent that this file here would be read more than once. Okay. Because for this to actually work, class C here, it needs only to be read once. Okay. So that's what you need to have is an include guard to prevent that. The include guard instruct the preprocessor to read a header file only once during the compilation of a single compilation unit. It will not prevent this file from being read from the perspective of another compilation unit, because this is another compilation run. Okay. So because of that, all header files without any exception, I can't emphasize this more or enough, all header files without any exception should always have an include guard. Even if you think, oh, it's not going to be reused, I know that because I know my code. Well, you know your code now, but next week, next month, next year, next decade, there might be somebody who will want to reuse this .h file somewhere else, and then we'll create something like this. And then what's going to happen is that when they compile this code here, it's going to fail. And that's not necessarily going to be very easy to figure out that this is the problem. Okay. Yeah, so that's why it's always the best habit is to put a include guard in. You create a new header file. First thing you do, put the include guard. Then you might say, and that's something I unfortunately see from time to time, some people that put an include guard in their CPP file. But you can have an include guard in your CPP file. There's nothing wrong with that. But there's absolutely no reason for you to have an include guard in a CPP file. Reason being that you should never, as I said before, and that's another thing I can't emphasize more, you should never have anywhere for any reason hash include a file.cpp, because that's essentially merging two compilation units together. So if there's no reason why you would hash include a.cpp, there's no reason for having an include guard. So if you see if you see a header include guard in the CPP file, big red flag here as a marker for an exam question, big red flag, somebody does not know what they're doing. Okay. And not that it's wrong and it's going to make the code fail, but big red flag, somebody does not know what they're doing. So how do you create a include guard? I already explained that. Pretty simple. I'm not going to repeat everything here. So either you have this style here, which is somehow using the if and def and hash if and def and hash hash defined, sorry, and hash and if constructs of the preprocessor to make it so that this file, this code here, is going to be read only once during the same compilation unit. And then each of the different files each have a different variable name here. So that's why the variable name is very often the name of the file itself. This is actually what was present in C. Okay, so that's been there for decades and decades now. But very long time ago in C++, they invented the notion of hash pragma ones. This is in fact doing exactly the same as this. It's of course much more succinct, easy to do. Why am I telling you about this here? Because you will see it all over the place. So if you don't know what that is, then yes, you might use this for yourself. Both of these things are doing the same. So sum up here, I'm not going to repeat that. This is essentially some of the things that I've said before. I invite you to read this here. It's a pretty nice sum up of some statements of things that you should do in the context of defining your header files, CPP files, and so on. Do and don't. So I'm listing them here, along with some explanations as to why is it that you should or should not do that. So, and that's it. That's it for this lecture. I really hope that this is going to be useful. Both, I would say, both to the people that had that were struggling with this aspect of C++ programming that I was able to see in some of the questions I asked in the midterm. And I also hope that it's going to be also useful for some students that had already some experience, and hopefully I will have taught you something in this video. Thank you. Bye-bye.